On November 16th, astronomers confronted a mystery that reshaped every assumption they held about interstellar visitors. What should have been a routine analysis of a newly observed object instead unfolded into the first chapter of a phenomenon that challenged both physics and probability. The object designated 3I Atlas was confirmed to have lost an extraordinary portion of its mass during its passage near the Sun, an estimated 13% amounting to roughly 4 billion tons of material, yet the expected signs of this violent shedding were nowhere to be found. No vast plume of dust, no incandescent tail stretching millions of kilometers behind it, no chaos of debris that should naturally accompany such a catastrophic release. Instead, the only visible signature was a faint and strangely uniform glow, as if the comet's body exhaled without disturbing the space around it. This contradiction became the first of 10 anomalies that would eventually be catalogued, each one statistically unlikely on its own, but collectively forming a pattern so improbable that traditional explanations strained under their combined weight. The early analyses, grounded in known models of cometary behaviour, quickly faltered as evidence mounted that Atlas operated outside the boundaries of typical physics. The comfortable assumption that interstellar comets behave like scaled versions of those born within the solar system collapsed almost immediately. Atlas did not drift in passively. It behaved as something with coherence and precision, shedding mass without trace, and moving in ways that gravity alone could not account for. Data coming in over the following days revealed that the object's deviations from expected motion were not the product of measurement error or observational gaps. NASA's Jet Propulsion Laboratory confirmed persistent non-gravitational acceleration, meaning that Atlas was changing course as if propelled by forces other than gravity. But the material that should have driven this acceleration was invisible, missing from every spectral band and every imaging sweep. Scientists were forced into an uncomfortable confrontation with probability itself. 1 anomaly can be dismissed. 2 are a curiosity, 3 demand caution. But 10 independent deviations, each contradicting well-established models, pressed the limits of statistical tolerance. When astrophysicists tried to calculate the likelihood that all 10 anomalies could appear in the same natural object by chance, estimates fell below 1 in 10,000, and some even dipped toward 1 in 100,000. This did not imply artificiality, but it did insist on humility. Our understanding of interstellar debris might be far narrower than we realized. The question, whispered rather than declared, began to surface across observatories worldwide. Was Atlas an extreme natural object, forged by conditions beyond our current imagination, or did its behavior hint at a phenomenon outside all familiar frameworks? As the first anomaly was logged and the data continued to accumulate, the object's journey through the solar system had only just begun. Each new observation promised clarity, but instead delivered deeper contradictions. What began on November 16th as a distant glimmer of light evolved into a scientific puzzle, vast enough to unsettle the foundations of cometary physics. Tianwen-1's unexpected role in the study of 3I Atlas began as a quiet redirection of mission priorities, a subtle change that would end up producing the sharpest images humanity had ever captured of an interstellar object. The orbiter, built for detailed surveys of the Martian surface, was never meant to track something fast, dim, and distant, yet engineers undertook the near-impossible task of recalibrating its instruments to lock onto a target that behaved nothing like a planet. Atlas, only a few kilometers across and coated in material darker than coal, reflected almost no sunlight, making it nearly invisible against the velvet void behind it. Worse still, it moved at extraordinary speed, 58 kilometers per second, crossing the frame of Tianwen-1's cameras faster than its predictive algorithms could comfortably manage. For weeks, corrections were uploaded, tested, undone, refined, and tested again, each adjustment pushing the probe to the limits of its mechanical precision. The effort gave scientists a rare sense of tension, because a single misalignment would mean losing the object forever in interstellar darkness. But eventually the improbable succeeded. Tianwen-1 locked onto the rapidly moving visitor and transmitted a sequence of raw monochrome images that stunned the astronomical community. The pictures did not reveal the chaotic, jagged emissions expected from a body undergoing violent solar heating. Instead, they showed a smooth, symmetrical glow surrounding the nucleus, a halo so uniform it seemed artificial in its serenity. There were no visible jets, no dust fans, no streaks of debris, none of the usual features that erupt from comets stressed by the sun's heat. It was as if the object deflected disorder itself. These images surpassed the clarity of Hubble's optics, surpassed even the crispness of the James Webb Telescope's infrared eyes, because Tianwen-1's vantage point orbiting Mars placed it uniquely close to Atlas compared with any Earth-based instrument. For the first time, the interstellar traveller emerged not as a blur of light or a theoretical dot on a simulated orbit, but as a tangible, structured entity. Yet with clarity came contradiction. The atmosphere around Atlas, its coma, wasn't turbulent or lopsided. It was eerily consistent, a softly expanding shell that behaved as though sculpted rather than naturally formed. No ordinary comet maintained such stability under intense solar radiation. The smoothness hinted at physical processes that astronomers could not reconcile with known cometary behavior. The absence of chaotic jets contradicted everything expected from an object shedding billions of tons of material. The orbiter's success, hailed at first as a technical triumph, rapidly evolved into a scientific dilemma. Tianwen-1 had delivered a portrait of something real but not recognizable, an object that obeyed geometry instead of entropy. In those strangely serene images, the mystery of 3i Atlas deepened, becoming not just a question of what it was, but whether existing physics was prepared to describe it at all. At the heart of the third anomaly lay a contradiction so sharp that it split established comet physics in two. 3i Atlas was accelerating as if pushed by powerful jets of escaping material, yet no observatory could find any trace of that material in space. The numbers themselves were unambiguous. NASA's Jet Propulsion Laboratory measured a persistent non-gravitational acceleration, acting on the object both radially and tangentially, exactly the kind of thrust produced when a comet vents gas or dust, with enough force to alter its trajectory. By calculating the required momentum, researchers determined that Atlas must have expelled roughly 4 billion tons of mass during its solar pass, the equivalent of stripping away a significant fraction of its entire structure in only a few days. Under normal circumstances, such a colossal release would transform a comet into a spectacular sight. A vast, luminous tail, radiant with dust, ions, and vapour, stretching millions of kilometres behind it like a torch blazing through space. Instead, the region behind Atlas was empty. The space around it remained eerily clean, with no plume, no reflection halo, no particle trail detectable across visible, ultraviolet or infrared wavelengths. Telescopes in Italy and Spain, along with data from Mars orbiters, confirmed the same impossible result. The object was accelerating, yet leaving nothing behind to cause the acceleration. Scientists initially suspected instrumental failure, but the measurements were independently confirmed by separate agencies and different spacecraft. The acceleration vectors were precise, consistent, and mathematically undeniable. What was missing was the mechanism. How could Atlas lose billions of tons of material without producing any observable debris? One theory proposed that the mass had been expelled in an ultrafine gaseous form, composed of molecules so small and so hot that their emissions fell outside the optical bands accessible to conventional instruments. But that hypothesis required temperatures and chemical processes far beyond anything observed in comets. Another suggestion invoked plasma behavior. Perhaps charged particles were released in a way that created no visible dust, forming instead an invisible sheath that carried momentum away without scattering light. Yet even plasma leaves spectral signatures, and Atlas offered none. A more radical idea, whispered rather than published, hinted that the material may have been expelled directionally with such precision that it behaved more like engineered thrust than natural venting, an uncomfortable speculation that most researchers were unwilling to entertain publicly. Emotionally, the anomaly struck the scientific community with a peculiar unease. It wasn't dramatic like a flare or visually stunning like a tail. It was an absence, a silence in data where noise was expected. In images where a luminous streak should have unfurled, there was only smooth, undisturbed blackness. The comet had changed its motion but erased the evidence of the act. This paradox, the reality of the acceleration and the invisibility of its cause, became a foundation of the wider mystery. It suggested that Atlas operated through physical processes not just unfamiliar, but fundamentally outside the patterns of natural cometary behavior. In that hidden momentum, scientists found the first hint that 3i Atlas might not be merely strange but unprecedented. Among the most unsettling discoveries surrounding 3i Atlas was its approach trajectory, which violated the most basic expectations for an interstellar visitor. Objects arriving from outside the solar system should come from random directions, scattered uniformly across three-dimensional space with no reason to align with our planetary plane. Yet Atlas slipped into the solar system almost perfectly along the ecliptic, the thin, invisible sheet where all major planets orbit entering with a tilt of barely 5 degrees, a value so small it matched the precision of bodies born within our own protoplanetary disk. This improbable geometry was compounded by an even stranger detail. Atlas was moving retrograde, travelling opposite the directional flow of all planetary motion, while still remaining locked into the same flattened plane. No natural mechanism comfortably explains both coplanarity and retrograde motion in an interstellar object. Statistically, the odds of such alignment occurring by chance hover around 1 in several hundred. But when the retrograde orientation is included, the probability drops even further. Researchers rechecked the orbital data multiple times, suspecting early observational error, but independent analyses from JPL, ESA, and CNSA confirmed the same result. The geometry was real. Atlas behaved as though it were threading a needle through the most structurally important plane of the solar system, matching its flatness with uncanny precision while sliding against its direction. Some attempted to explain this using galactic models, suggesting that Atlas might be part of an unseen stream of interstellar debris moving in alignment with the Milky Way's gravitational mid-plane. But no evidence of such a stream has ever been documented, and even if it existed, it would not naturally produce such an exact solar system-specific alignment. Others speculated that gravitational interactions in its home system could have flung it outward in just the right direction, but the required conditions were so extreme and finely tuned that they bordered on implausible. Beyond calculations and models, the emotional effect of the discovery was profound. For astronomers, the ecliptic is more than a dynamical coordinate. It is the architectural foundation of the solar system, the stage upon which all known planetary motion unfolds. To see a foreign object enter through that very plane, aligned so cleanly and yet moving backward through it, felt like witnessing a signature written in a script that mimicked our cosmic handwriting. It made the object feel less like a random traveller and more like something that had chosen its path. In scientific reports, the anomaly was described with clinical neutrality. Inbound trajectory exhibits improbable coplanarity, combined with retrograde motion. But behind those reserved words, researchers recognized a deeper implication. Atlas was not behaving as a piece of wild interstellar debris. It was navigating, or at least moving in a way that suggested precision. This alignment marked the moment when many scientists privately acknowledged that the ordinary language of celestial mechanics was no longer sufficient. The universe was presenting something that fit the equations, yet defied the expectations behind them. The fifth anomaly emerged during the mid-2025 observation window, when telescopes across Japan, Italy, Chile, and several orbital platforms recorded an event that should have been physically impossible. 3i Atlas unleashed a jet of material that pointed directly toward the Sun. In cometary science, this is not merely unusual, it contradicts one of the most unbreakable rules in astrophysics. Cometary jets, formed when sunlight heats volatile materials and causes them to sublimate, are always pushed away from the Sun by radiation pressure. This outward force is so absolute and so predictable that astronomers often determine a comet's orientation solely by analysing tail direction. Yet Atlas defied this cosmic compass completely. The jet did not bend backward or become swept away by solar wind within seconds. Instead, it held its orientation for nearly 48 hours, a sustained, unwavering emission directed into the face of the Sun, as though resisting the most dominant force in the inner solar system. Early theories tried to reconcile the observation with known physics. Perhaps it was an anti-tail effect, a geometric illusion that occurs when Earth crosses the comet's orbital plane. But this explanation collapsed immediately, because multiple observatories located across widely separated longitudes and latitudes all recorded the same sunward orientation from different viewing angles. Geometry could not account for the behaviour. Another hypothesis suggested that Atlas might harbour a cavity on its surface, a vent angled in such a way that rotational spin briefly aimed its emissions sunward. but the forces required for such orientation would have torn the nucleus apart, and even if the vent could point toward the Sun, the emitted particles should have been blown backward almost instantly. Yet the jet remained stable, undistorted, and clearly visible across repeated exposures. Scientists next considered the possibility of magnetic shaping, imagining that interplanetary magnetic fields might redirect the flow. But near 1 astronomical unit from the Sun, the magnetic field is far too weak to structure a jet so precisely, and certainly not against the raw pressure of solar radiation. As each explanation failed, the event began to resemble something not reactive but directiveless, like venting, and more like thrust. The very idea unsettled researchers. No natural comet has ever demonstrated anything remotely resembling controlled emission, and the notion that Atlas might be exhibiting vector-specific force was met with caution, even quiet discomfort. Yet the data offered no comforting alternative. Emotionally, this anomaly carried a mythic quality. There was something profoundly symbolic about an object turning toward the Sun, our system's gravitational and energetic monarch, and pushing into its power. The jet's steady resilience seemed almost intentional, as if Atlas were defying a command written into the physics of all comets. Official summaries reduced the phenomenon to technical phrasing: sustained jet emission observed opposite expected solar vector. But every scientist who examined the images felt the deeper truth behind the sterile words. Atlas had violated a foundational law of cometary behavior, not by accident, but with astonishing steadiness. And in that defiance, a new layer of mystery unfolded, an object from another star system, behaving with a precision no known natural process could easily explain. The sixth anomaly confronting astronomers was the sheer paradox of 3I Atlas's size and speed, two properties that, according to every established model of astrophysics, should not coexist in a single naturally ejected interstellar object. Atlas's nucleus measured roughly 5.6 kilometers across, a massive city-scale body that should have been far too heavy to accelerate to the velocity it carried when entering the solar system. At 58 kilometers per second, or roughly 129,000 miles per hour, Atlas moved faster than any known comet of comparable mass, surpassing even the escape velocities expected from chaotic gravitational slingshots around large planets or binary stars. Smaller fragments can achieve such velocities: lightweight shards, debris from collisions, splinters of shattered worlds. But a body millions of times more massive than Oumuamua and vastly heavier than Borisov should remain gravitationally bound to its home system unless acted upon by truly extreme forces. Scientists began by considering the orthodox explanation. Perhaps Atlas had gained additional acceleration from the Sun's gravity as it approached. But archived observations from deep space telescopes indicated that Atlas already possessed hyperbolic, unbound velocity even before entering the heliosphere. This meant the Sun merely curved its trajectory. Its speed was inherited, not acquired. Alternative models invoked catastrophic stellar events. Perhaps a close encounter with a neutron star or black hole had hurled the object outward with tremendous energy. Yet such interactions typically tear objects apart, not preserve them intact. Atlas showed no signs of structural fragmentation. Others proposed that Atlas might belong to a rare hyperbolic stream of objects travelling through the galaxy, remnants of ancient gravitational tides or interactions with massive stellar clusters. However, no other body has ever been documented along this trajectory, and statistical models predict that objects of Atlas's size should be among the least likely to populate such a stream. The deeper scientists dug, the stranger the contradiction became. It wasn't only that Atlas was too big to be moving so fast, it was that its velocity and mass were coupled in a way that seemed to violate the expected distribution of interstellar debris. The rarest objects should be slow, and the fastest should be small. Atlas was neither. Emotionally, this anomaly struck astronomers as a kind of cosmic rebellion. The data felt like a deliberate inversion of natural probability, a combination of traits that should cancel each other out but instead existed in perfect tandem. One researcher described Atlas as a bullet forged from statistical impossibility, a description that resonated across the astrophysical community. In technical reports, the anomaly was summarized cautiously. Object exhibits non-standard mass-velocity profile, inconsistent with known ejection scenarios. But behind those restrained words lay an uncomfortable recognition. Either Atlas was a natural product of conditions far beyond the range of environments we have documented, or its journey across interstellar space followed rules or forces that did not fit any familiar pathway. The sixth anomaly made clear that Atlas was not merely unusual, it was dynamically unprecedented. A traveller propelled by origins still obscured in the darkness between the stars. The seventh anomaly emerged not from the object's composition or motion, but from the eerie precision with which 3I Atlas threaded its way past the major observational posts of the inner solar system. As astronomers reviewed its trajectory, they noticed a pattern so improbable that it felt almost choreographed. At each planetary crossing, Atlas passed within ideal viewing distance of spacecraft that happened to be active at precisely the right moment. In September 2025, for example, the object swept past Mars at a distance that allowed both Mars Express and the Trace Gas Orbiter to capture high-resolution measurements, an alignment that would have been impossible had Atlas arrived even days earlier or later. Then, weeks afterward, its path curved near Venus during a period when several orbiters around the planet were fully operational and not in safe mode, an unlikely occurrence given the sporadic nature of planetary mission schedules. Later still, Atlas skirted the outer reaches of Jupiter's domain, close enough to be tracked but far enough to avoid gravitational capture, offering another perfect window for long-range observation. Each encounter could be dismissed individually as chance, but the cumulative pattern pushed beyond statistical comfort. The most unsettling moment came at perihelion, the point where Atlas approached within 0.9 AU of the Sun and should have reached maximum brightness. Instead, the Sun aligned directly between Atlas and Earth, rendering the object invisible to every ground-based telescope at the exact moment scientists most needed to see it. For weeks, Earth's daylight masked its location completely. The probability that an interstellar object would, by random luck, hide behind the Sun during its peak luminosity was calculated at roughly 1 in 20,000. Meanwhile, spacecraft around Mars, Venus and elsewhere still maintained line of sight, enabling multiple off-Earth instruments to continue monitoring it. To engineers and mission planners, the trajectory resembled something optimized for reconnaissance, a flight path that maximized visibility to remote outposts while minimizing exposure to the most heavily monitored vantage point Earth. Scientists were careful not to imply intention, yet privately the timing raised uncomfortable questions. Could such a path result from interactions in Atlas's home system? Could unknown gravitational influences shape its track so precisely? Or was this simply an extraordinarily unlikely coincidence, the universe producing a sequence of alignments that looked purposeful but were not? Even the conservative explanation struggled to quiet the unease. Emotionally, the scientific community sensed something uncanny in the geometry of Atlas's journey. A rhythm that did not match the chaotic nature expected from a 5.6-kilometre lump of ancient material. Reports summarise the phenomenon with sterile phrasing. Perihelion passage coincided with solar conjunction from Earth's perspective. But the lived experience of those tracking it was far more intimate, a sense of watching an object moving not blindly, but with a strange compatibility to our observational infrastructure, as if the sky itself had momentarily aligned to keep Atlas visible only where we were least prepared to look. The eighth anomaly emerged when astronomers dissected the spectral fingerprint of 3I Atlas and uncovered a chemical composition so abnormal that it disrupted every established model of comet formation. When the first spectroscopic data arrived from ESA, JAXA, and several ground-based observatories, scientists expected to see the familiar dominance of iron over nickel and elemental hierarchy found consistently across every known comet in the solar system. Instead, they were confronted with the opposite, nickel lines blazing brighter and more intense than iron by a wide margin. This was not a minor deviation. It was a categorical inversion. Natural comets do not form with nickel-rich cores, and certainly not with nickel overpowering iron to such an extent. Yet Atlas displayed a signature almost metallic in purity, as though forged in a high-temperature environment where only the densest elements could remain. Even more baffling, the spectra revealed unusually strong signals of nickel cyanide compounds, concentrations far exceeding anything ever seen in cometary bodies, 10 times stronger by conservative estimates, possibly hundreds of times higher in some readings. At first, teams suspected contamination, or calibration errors, but repeated checks and redundant measurements across different instruments confirmed the same chemical structure. The data were real. That forced astrophysicists to rethink what kind of stellar nursery could produce such a composition. One hypothesis suggested Atlas may have formed close to a hot, massive star where volatile elements would have boiled away early, leaving behind a metal-rich body. But even that scenario could not account for the extreme purity of the nickel signals or the absence of secondary markers like magnesium, silicate impurities, or mixed metal residues. Another proposal invoked unusual interstellar processing. Perhaps Atlas had drifted for millions of years through dense cosmic clouds that altered its surface chemistry. Yet the depth of the nickel signature implied the anomaly extended far beneath the surface layer. A more unsettling comparison emerged quietly in laboratory discussions. The spectral ratios resembled industrial nickel alloys used on Earth in aerospace engineering, materials designed to endure extreme heat and structural stress. No one claimed Atlas was artificial, but the resemblance was impossible to ignore. In workshops and private correspondence, scientists admitted the shape of the data felt engineered, selective, efficient, lacking the chaotic mixture typical of natural formation. Emotionally, this realization marked a turning point. Until this point, many anomalies could be framed as improbable dynamics or unlikely geometry, but composition lies at the heart of identity. A comet's chemistry is its birth certificate, a record of the conditions under which it formed. And Atlas's chemistry did not match the signature of anything born in our solar system or in any modelled protoplanetary environment. Official summaries softened the blow, describing the anomaly as unusual nickel enrichment inconsistent with known cometary formation scenarios. But beneath that cautious phrasing lingered the darker implication. Atlas might not merely be a traveller from another star system. It might be forged from matter shaped in ways the cosmos has rarely revealed, or perhaps shaped with intention. The ninth anomaly forced astronomers to re-evaluate the very definition of a comet, because 3I Atlas behaved like an object almost entirely devoid of water, yet still displayed vigorous outgassing and extraordinary structural integrity. Spectral analysis revealed that only about 4% of its total mass consisted of water ice, a value so low it fell far outside every known cometary profile. Typical comets in our solar system contain between 70 and 80% water, their activity driven by sublimation as they approach the sun. Water is the engine that powers jets, creates luminous comet, and fuels the classic tail that trails behind them. Without it, a comet should be inert, silent, and largely invisible. But Atlas was anything but. During its solar passage, the object expelled material with a force equivalent to billions of tons of mass loss, producing measurable non-gravitational acceleration, and yet its surface showed none of the chaotic fragmentation that should accompany such extreme thermal stress. A body this dry should have cracked violently as the sun's heat tore through its volatile components. And yet Atlas remained structurally coherent, its coma faint but perfectly stable, its nucleus intact. Nothing in its behaviour matched the expectations for an object with so little water content. Scientists first considered whether Atlas might have formed in a high-temperature environment close to a hot star, where ices would have evaporated early in its history, leaving behind a metal-rich, desiccated core. But this hypothesis raised more problems than it solved. A body stripped of volatiles should not produce sustained jets, nor should it survive repeated episodes of heating without disintegration. Others speculated that Atlas might have accumulated a thin layer of volatile dust through interstellar drift, perhaps enough to generate temporary activity. But this could not account for the massive multi-billion-ton mass loss event detected near perihelion. If Atlas truly contained only 4% water, then its jets must have been powered by something else entirely. Some proposed that exotic compounds such as vaporizing silicates, metal-rich ices, or nickel-based gases might fuel the emissions. Others suggested that internal processes could regulate the release, more like a controlled venting mechanism than chaotic sublimation. Yet all such ideas stretched the boundaries of known geophysics. The deeper implication was that Atlas behaved not like a fragile ball of ice and dust, but like a hardened traveller, an object, built, sculpted, or naturally forged for endurance across unimaginable distances and hostile environments. Emotionally, this anomaly carried a haunting quality. to see a comet survive conditions that should have destroyed it, while operating with a dryness more extreme than any comet known, evoked an image of something carved by pressure and time into a form optimized for survival. A cosmic relic stripped down to its most resilient essence. Official summaries attempted to keep the tone measured, noting merely that volatile fraction is significantly lower than predicted by cometary models. But behind the restraint was a quiet astonishment. A comet without water that still breathes, moves, and endures, that is not a simple outlier. It is a contradiction made manifest, an object that challenges the very categories into which we sort the universe's wanderers. The 10th anomaly emerged when researchers analysed how 3I Atlas interacted with light, revealing optical behaviour so extreme that it contradicted every established model of comet surface physics. Instruments from ESA's Gaia mission, several large ground-based polarimeters, and spectral imagers aboard orbiters around Mars and Venus all recorded the same bizarre phenomenon. Atlas exhibited extraordinarily strong negative polarization across a wide range of phase angles, far beyond anything documented in natural cometary bodies. Negative polarization occurs when light scattered by a surface becomes aligned in a direction opposite to what standard physics predicts, typically arising from fine dust particles, microstructures, or specific refractive properties. But the magnitude observed in Atlas was staggering, several times stronger than even the darkest, densest comets known. At certain angles, the polarization dipped to values that bordered on optical inversion, an effect that should require a surface with precisely engineered textures or a composition capable of manipulating light at microstructural scales. Attempts to explain this through natural mechanisms faltered quickly. Ordinary comet dust, even in exotic grain sizes, cannot produce polarization curves this extreme. Ice crusts and metal-rich surfaces offer no path to such behavior either. Some researchers propose that Atlas might be coated in an ultrafine layer of metallic microflakes or complex plasma-bound particulates, but such materials would typically reveal themselves elsewhere in the spectrum. Atlas did not. The object absorbed nearly all light in visible wavelengths, reflecting so little that it appeared almost like a silhouette against space, yet simultaneously produced the pronounced polarization signature of a surface interacting with light in a highly organized fashion. Another hypothesis explored the possibility of a plasma sheath enveloping the nucleus, a thin boundary of charged particles created by unusual outgassing or interstellar processing. Plasma can alter polarization under certain conditions, but maintaining a stable sheath for months while the object experienced intense solar heating seemed implausible. Furthermore, most plasma effects vary rapidly with time, yet Atlas's polarization remained remarkably stable. The implication, though rarely stated aloud, was troubling. The surface or surrounding material behaved more like something designed to manipulate electromagnetic scattering, rather than something shaped by random cosmic processes. In private discussions, scientists compared the data to engineered metamaterials, structures humans create to bend or reshape light in specific ways. The analogy was imperfect, yet it captured the unsettling precision of Atlas's optical behavior. Emotionally, this anomaly deepened the sense that Atlas was not simply unusual, but purposefully strange, an object whose very interaction with light defied the expected disorder of natural bodies. Reports attempted to maintain composure, describing the event as unprecedented polarization values inconsistent with known particulate or icy surfaces. But behind the tempered language was a quiet recognition shared across observatories. Atlas was not merely reflecting sunlight, it was manipulating it, shaping it in ways no comet should, as if the object were wrapped in a material or structure meant to suppress visibility, absorb illumination, or control the way it appeared to distant eyes. The 11th anomaly emerged from a coincidence so unsettling that even the most conservative researchers struggled to dismiss it. The inbound trajectory of 3I Atlas passed within roughly 9 degrees of the region of sky, associated with the famous 1977 WOW signal. That signal, an unexplained 72-second burst of narrowband radio energy, detected by the Big Ear Observatory, had been a staple of SETI discussions for nearly 5 decades. Widely considered the most tantalizing candidate for an extraterrestrial transmission ever recorded. For years, astronomers debated whether it originated from a natural source, an unknown astrophysical event, or something more deliberate. No one expected it to intersect, even tangentially, with the path of a massive interstellar object entering our solar system. Yet plot after plot confirmed the geometry. As Atlas traced its hyperbolic arc inward, its radiant, the point on the sky from which its motion appeared to originate, fell strikingly close to the coordinates of the 1977 signal's best-fit location in the constellation Sagittarius. The alignment was not perfect, and no responsible scientist claimed it indicated intent. But the statistical improbability was enough to prompt renewed scrutiny. CT teams across the globe began retargeting their arrays toward the region, sweeping across the object's path with a level of intensity not seen since the early 2000s. Dozens of radio telescopes, including FAST in China, Meerkat in South Africa, and multiple deep space listening posts joined in coordinated observation campaigns. Their efforts yielded no transmissions, no modulated patterns, no repeat of the famous narrowband spike. Atlas remained silent across all monitored frequencies, yet the absence of a signal did little to ease the unease. The coincidence alone rekindled discussions about interstellar objects as potential carriers of information or as debris from civilizations long gone. Most scientists rejected such speculation outright, but privately many admitted that the correlation was difficult to ignore. After all, Atlas was only the third confirmed object of interstellar origin ever detected, and statistically the number of random intersections with historically significant sky coordinates should be essentially zero. What troubled researchers most was not the possibility of intent, but the implication that the WOW signal's origin might lie in a region of space capable of producing objects like Atlas. If the same stellar neighborhood could create a body with 10 unprecedented anomalies, massive non-gravitational acceleration, impossible chemical composition, bizarre optical properties, then perhaps the 1977 signal was not an isolated curiosity, but an early hint of a deeper pattern. Emotionally, this anomaly stirred a mixture of excitement and dread. For those who had spent decades confronted only with silence in the search for extraterrestrial intelligence, the idea that two unrelated mysteries might share a point of origin felt like an echo across time. It did not prove anything, but it suggested the universe might be less random than assumed. Official reports minimized the drama, noting only that Atlas's radiant lies within a limited angular distance of historical city interest regions. But behind the careful wording lingered a quiet electric tension. If nature had arranged this overlap by chance, it was an astonishing coincidence. And if it wasn't chance, then something far more profound was unfolding in the dark between the stars. The 12th anomaly emerged during the period when 3i Atlas underwent a transformation so dramatic and so prolonged that it forced scientists to reconsider every assumption about how interstellar objects respond to solar heating. For 70 uninterrupted days, the comet brightened by a factor of 5 while emitting an intense, blue-shifted glow, yet without producing any detectable increase in dust, gas, or mass loss. In ordinary comets, brightening is the direct result of volatile material erupting from the nucleus, releasing dust into the coma and forming spectacular tails that scatter sunlight across a broad spectrum. But Atlas defied this pattern entirely. Its luminosity increased smoothly, almost mathematically, with none of the chaotic flickering expected from violent outgassing. More troubling, spectral analysis showed that the brightening was dominated by blue wavelengths, an emission profile suggesting high-energy excitation rather than simple reflection. Blue emission in comets typically originates from ionized carbon or excited molecular fragments produced in turbulent jets, but Atlas generated no such fragments. Instruments that should have detected surges in particulate density, ion concentration, or volatile species reported flat lines. The object brightened without shedding mass, as if the glow emerged not from released material, but from the surface or surrounding environment itself. Researchers proposed several explanations, each more speculative than the last. One team suggested that the nucleus might contain exotic compounds capable of luminescing under thermal stress, but the energy required to sustain such emission for 70 days exceeded anything chemically plausible. Another group hypothesized that interstellar irradiation could have created an ultra-thin metallic coating that fluoresced when heated, but this conflicted with the object's extreme darkness and nickel-heavy spectra. Plasma physicists offered a more radical idea. Perhaps Atlas was enveloped in a stable plasma sheath, a thin, energized layer capable of re-emitting solar radiation in higher energy wavelengths. Plasma can create blue emissions under certain conditions, but maintaining a coherent uniform sheath for months would require constant energy input and a mechanism to regulate density properties no natural comet has ever displayed. More unsettling was the stability of the brightening curve. Natural comets flare in bursts driven by uneven surface geography, fractures, and pockets of volatile materials. But Atlas's luminosity rose with uncanny consistency, as though following a controlled function rather than responding to the irregular topography of a natural body. The emotional effect of this anomaly was profound. Scientists describe the phenomenon as serene, unnervingly calm, and alive with purpose. For 70 days, Atlas shone ceaselessly, a blue beacon drifting through the inner solar system, glowing without shedding, illuminating without burning. To many observers, it felt less like a natural flare and more like a signal, or at least a process that behaved with the coherence of one. Official summaries tried to contain the strangeness, noting merely that the object exhibited sustained blue wavelength enhancement without corresponding increases in particulate output. But among astronomers who watched the data stream in night after night, the impression was unmistakable. Atlas was not reacting to the sun the way a comet should. It was doing something else entirely, something steady, powerful, and eerily self-regulated, as though the object were activating a layer of physics that comets are not supposed to possess. The 13th anomaly brought scientists back to the contradiction that had haunted every stage of the investigation. The missing 4 billion tons of material that 3i Atlas was proven to have lost, but that no instrument anywhere in the solar system ever detected. This wasn't a theoretical discrepancy or a measurement error. Multiple independent datasets, from JPL's trajectory calculations to ESA's orbital reconstructions to Mars orbiter Doppler shifts, showed that Atlas experienced a non-gravitational acceleration that could only be explained by massive mass loss. Yet across every wavelength visible, ultraviolet, infrared, radio, and even narrowband ion detection, the region around the comet remained impossibly clean. There was no tail, no dust plume, no debris cloud, no ionic stream, nothing that could account for billions of tons of expelled matter. Under normal conditions, even a fraction of that mass loss would have produced a tail stretching tens of millions of kilometers. Cometary debris should have scattered sunlight, interacted with solar wind, ionized under ultraviolet radiation, and left a detectable fingerprint across at least one spectral band. But Atlas left nothing, not even a thin haze. Scientists explored increasingly exotic hypotheses. One idea suggested that the expelled material might have been composed of ultrafine gas molecules moving so fast and so directionally that they dispersed before reflecting measurable light. But the thermal conditions required for such velocities were absurd far hotter than anything a comet nucleus should survive. Another theory imagined molecular species invisible to standard spectrometry, but such species would still leave indirect signatures through photon scattering or magnetic interactions. Atlas showed none. Plasma theorists proposed that the object might be ejecting charged particles that immediately locked into the solar magnetic field and disappeared from view. But particle detectors on spacecraft near Venus and Mars detected no anomalies, no abrupt spikes or missing flux. A more radical line of thinking considered whether the mass loss might not be loss at all but transformation. Perhaps the material was converted into a non-reflective form, or vented as highly directional jets so precisely collimated that they mimicked engineered thrust. Such a possibility made many scientists uncomfortable, because no natural comet has ever shown mechanism-like efficiency in channeling force without debris. If Atlas truly expelled billions of tons in a narrow invisible stream, it would imply the presence of internal structures or processes that resembled control systems more than chaotic sublimation. Emotionally, this anomaly struck the scientific community with a sense of profound wrongness. Nature's messy entropy leaves trails. Explosive mass loss should create chaos. Yet Atlas behaved like an object that concealed evidence of its own processes, shedding mass without leaving residue, accelerating without ejector, moving with the discretion of something aware of its own visibility. Observers described the data as haunting and eerie, because the absence of expected signatures felt more revealing than their presence would have. The missing tail became more than a scientific problem. it became a symbol of the object's deeper strangeness, the quiet core of the entire mystery. Official documentation softened the language, noting only that the comet exhibited non-gravitational acceleration inconsistent with observed particulate output. But to those who spent months studying the anomaly, the truth was clear. A comet had performed an act that nature does not perform, hiding 4 billion tons of its own body as though erasing its tracks. And in that erasure lay the most unsettling question of all. What kind of object loses mass without letting the universe see it happen? The 14th anomaly was not a single data point, but the realization that all 13 preceding anomalies, when combined, formed a statistical portrait so improbable that it strained the limits of scientific language itself. Researchers across institutions began constructing Monte Carlo simulations to estimate the likelihood that a naturally formed interstellar object could display this exact combination of properties. The impossible acceleration without ejector, the nickel-heavy chemistry, the sunward jet, the perfect ecliptic alignment, the 70-day blue luminosity, the dryness, the optical inversion, the mass-velocity paradox, the missing billions of tons of material, and the uncanny proximity of its radiant to the wow signal coordinates. Each anomaly alone was rare. Together they created a configuration that defied intuition. Conservative models placed the combined probability at less than 1 in 10,000. More aggressive models pushed it toward 1 in 100,000, numbers so extreme that they forced astronomers to reckon with the fragility of their existing assumptions. 2 interpretive camps gradually emerged. The first insisted that Atlas must be a natural object forged in a stellar environment humans have never observed, perhaps near an exotic type of star or in a region of space where unknown physical processes shape matter in unfamiliar ways. They argued that the universe is vast enough to produce such outliers, and that discovering one should expand, not challenge, the boundaries of known astrophysics. The second camp approached the problem differently, not claiming artificiality, but exploring the possibility that Atlas's behavior aligned with scenarios typically associated with deliberate engineering. Directional mass loss resembling thrust, surface properties that manipulated light, emission events with mathematical smoothness, and a trajectory that seemed optimized for visibility to spacecraft rather than to Earth. This was the intentionality-compatible interpretation, not declaring purpose, but acknowledging that the object's traits were consistent with mechanisms that in human contexts would be considered controlled. Into this intellectual tension stepped figures like Avi Loeb, who urged the community to evaluate extraordinary data without flinching. Loeb emphasized methodological openness, arguing that ruling out unconventional explanations before investigating them was as unscientific as assuming them prematurely. His stance gave many younger researchers the freedom to consider hypotheses that would have been taboo a decade earlier. Yet even Loeb refused to leap to conclusions. He pointed out that nature itself often produces patterns that mimic intentionality, and that the burden of proof for any extraordinary claim must be overwhelming. Emotionally, this final phase of analysis marked a shift from fear to awe. Scientists who had once described Atlas as unsettling or eerie now spoke of it with a kind of reverence, as if the object had revealed not a threat, but a deeper layer of the cosmos's design. The mystery no longer centered on whether Atlas was natural or artificial, but on what it implied about the universe, that it may harbor processes, environments, or histories so far beyond terrestrial experience that they blur the line between physics and intention. Official reports ended cautiously, summarizing the object as a statistically extreme outlier with unexplained dynamical, compositional, and optical properties. But those who had followed Atlas from its discovery knew that this phrasing barely scratched the surface. In private conversations, many admitted that the encounter had changed them, that after Atlas, the solar system felt less isolated, the universe less indifferent, and the boundaries of the possible far wider than they had imagined.